Welcome. Let's try to solve a Leetcode problem 1246, palindrome removal. So the idea is that we are giving an array, and this is going to be an integer array. So inside of the array, for example, in the first example, we have two numbers, and we're going to return the minimum number of removals needed to remove all numbers from the array. Yeah. So normally, for this array with 1 and 2, we can remove 1 and only 2 left behind, and then we can remove 2. So how many steps? There are going to be 2 steps. Yeah, but this is not the most efficient way to solve the problem. Yeah. So for another example, if we have 1, 3, 4, 1, 5. Yeah. If we remove 1 by 1, it's going to be 5 times. But we want to improve the efficiency according to the description. So why not we remove 5 first? It is 1 time, and then we remove the left part. And for removing the left part, why not we just remove this 4 first and then remove 1, 3, and 1. So how many times? In total, there are going to be 3 times. Yeah. But the difficult part is about 1, 3, 4, 1. Yeah, let's just analyze the sub-problem for 1, 3, 4, 1. How can we just remove 4 first and then we're going to remove 1, 3, and 1? It's going to be really difficult. Yeah. So according to the palindrome removal and the structure of the problem, basically, now we're going to solve it by using the interval dp or range dp. The definition of the interval dp is from the range I to j. This is the definition for fi to j. I want to get the minimum number of moves needed to remove all numbers from the array. So this is the definition. Yeah. So currently, how can we remove this 4 first and then remove 1, 3, and 1? It's going to be really difficult. But our idea is from the beginning, why not we just split it? Yeah. Currently, this one equal to this one. It is okay. There are 2 ways basically, and we can remove the left and the right first. So what left behind? It's going to be with 3 and 4. Yeah. We remove 1 and 1. And what we left behind is the 3 and 4, but we didn't count as 1 because this 1 and 1 can also combine with the others. Maybe we're gonna remove a 3 and then remove a 4. Yeah. So remove 3 how many times? It is 1 time. And remove 4 how many times? It is another 1 time. So it is 2 times. Yeah. But while we are removing this one and this one, we didn't count it because it is a palindrome because they are equal. Yeah. So 2 plus. So there are 2 times for this whole part, and before for this 5 there is another one, so it's gonna be 3 times. Yeah, so this is one of the possible way for analyzing the problem. Yeah, and another way is even they are equal, I cannot do this directly. Maybe this is not the most efficient way. Yeah, maybe I have to split it to check. So let's just use another example. Even they are equal. So I'm going to use 1, 2, 1 and 1, 2, 1, 3, 1 as another example. Yeah. So if we remove the left and right part, so it is okay. Now what we left behind is 2, 1, 1, 3. Yeah. Currently we are going to remove this part, but they are not equal. Yeah. But how should we solve with the not equal problem? Yeah. So we should know that 1, 2, 1, this is one part, 1, 3, 1, it's another part. So in total, it's going to be 2 removals. Yeah. But if we solve it from the left ends and the right ends, yeah, we can remove this one and this one. It is okay, but we didn't count it. Now we come to the problem with 2 and 3. So if they are not equal, how would we do that? So maybe we're gonna want to split it into 2 parts. Yeah, maybe split it with 2, 1 and 1, 3. How many times? With 2, 1, it's going to be 2 times. 1, 3 going to be 2 times. Yeah, it's going to be 4 times. Yeah, it's not the most efficient way to do it. Yeah, maybe we want to split it like 2 and 1, 1, 3. For 2, we need 1 removal. What about 1, 1, 3? For 1, 1, 3, we can split it as 1, 1, and 3. So it's going to be another 2 removal. So 1 plus 2, it is 3. But it's not the minimum because our minimum is going to be 2. But how can we make it to be 2? Can we directly use it like that? No. Yeah, let's just go back. Yeah. we remove the left side and the right side, but in the middle, there are 4 numbers. No matter in which way we split it, they're going to be 3 times minimum. Like 2, 1, 1 with 3, it's going to be 3 times. It means this is not okay. Yeah. Even they are equal, we can solve it. We can combine it in 2 ways. One way is we're gonna delete the left and the right because they are equal, and we solve the problem, solve the subproblem with I plus 1, z minus 1. Yeah, with this 3 and 4. Another one is, even we get the minimum, we're gonna record it as a minimum as a result, but it's not the minimum yet. We have to split it. For example, we're gonna split it from here with 1 to 1, 1, 3, 1, so it's gonna be 2. So we're gonna get our minimum value. Yeah, this is for equal. But what if they are not equal? So let me use another example if they are not equal. Yeah, so I'm gonna use 1, 3 with 1, 4 as another example. Yeah, so we have another example 1, 3, 1, 4. Yeah, so this is gonna be easy. If they are not equal, left and right, so we're gonna directly split it, because this is gonna be the most efficient way. If we did not split it, it's gonna be 4 times. 4, 1, 3, 1. We remove each number 1 time. But what if we split it from here? This is just 1 time. This is another 4 is just another 1 time. So it's gonna be in total 2 times. So this is not equal. Yeah. So basically, we want, because the array is continuous. Yeah. Because the subarray gonna be contiguous, so we have to split it into 2 parts like that. Yeah. And now it comes to the edge cases. So the edge cases comes like that. Yeah. So the edge case is going to be like what we left behind. This is I and this is j, and j equal to I plus 1. And if they are equal, so we're going to count it. So there's only 1 count because they are equal. It is a palindrome. We can remove it together. It is a palindrome. If they are not equal, maybe we have a 1 and 2. They are not equal. So how many removals? This is I. And z equal to I plus 1. I plus 1 is here. And they are not equal. We're going to need 2 removals. Yeah. And another case is there is only 1 number. Like what we left behind is only 1 or 2. So how many removals? There's only 1 removals. Yeah. So that is all the edge cases. Now I think it's enough for us to prepare to solve the problem. So as I explained, I'm going to use DFS plus memorization because this is much easier to understand than the tabulation. So I'm going to use the case with a DFS from I to j. So finally, I'm going to call this function. So it's going to be the DFS from 0 to length of the array minus 1. So the definition of the DFS ij is going to be the minimum number of removals needed to remove all numbers from the array in the range I to j. So this is a 0 to length of the array minus 1. This is the range. Yeah. Now let's just check the edge cases first. So the edge case is going to be 2 cases. So for one case, say that for I equals to j. So we're going to return a 1 directly because it is only 1 character. It is okay. But what if I plus 1 equal to j? Yeah, so this means I equal to j minus 1. It's the same because that's just next to each other. J equal to I plus 1, I equal to I. So we're going to return a 1 if they are not equal. So if array I and if they are equal, we're going to return a 1. If array I equal to array j, we're going to return a 1. If they are not equal, we're going to return a 2 because at least we're going to need 2 removals. Yeah. Now we go to the 2 parts. So for the first part is, let's say 2 adds. Let me just use 2 adds not equal because this is going to be easier to analyze. So if they are not equal, so I'm going to use index k to split it into 2 parts. So for k in range, here we're going to starting from I because at least we're going to have 1 character. It cannot be empty. Yeah, so we're going to starting from I, and for this k, going to add with let me check. So it's going to be add with j. Yeah, because we're going to split it into 2 parts. The other part should at least have 1 character. So it's going to be in the range from I to j. And now we're gonna split it into two parts. We're gonna need to record the minimum value. So I'm gonna set a result to be the infinity. Yeah, because I'm going to calculate the minimum. Yeah. Now I'm gonna check the minimum of the result. So it's gonna be the minimum of result with DFS. So from I to here, it's gonna be from from I to k, and the minimum of k is gonna be I. It means a single character, because at least we need a character. So it's gonna be plus DFS. This is gonna be k plus 1 to j. K plus 1 means if this so this k plus 1 means if this k equal to j minus 1. So j minus 1 plus 1, it's going to be j. DFS jj, it means there's only one character. So this is why I needed to have a k plus 1 to j. Yeah, so this splitting include all the different cases. So for example, we have number 1, 2, 3. We can split it here. We have this one, or we can split it from here. There are two different of splittings. Yeah. Now let's just continue. So this is for they are not equal, but another case is that two edges gonna be equal. Yeah. Another case is two edges equal. Yeah. If they are not equal, I have to check, right? Let me just put it here. Maybe let me put it here. Yeah. So if they are not equal, I have to check. So if array I not equal to array j, this means they are not equal. So I'm gonna enumerate all the different cases and check the minimum value. Yeah. So the second case is that they are equal. Let me just copy the same code, because basically I just needed to change a little bit. It's gonna be okay. So if they are equal, I'm gonna record a result first. Yeah. So this is I've already explained earlier. It's gonna have two different cases. One case we're gonna also include in this case. We're gonna split it. Another case we will not split it. It's gonna be the minimum of the two different cases. If they are equal, we may not split it. This is gonna be maybe one of the possible results. So it's gonna be I plus 1 to j and minus 1. Yeah. So let me just use an example for this case. Yeah. So sometimes we're gonna have the numbers like 1, 2, 3 with 2, 1. Yeah. So if they are equal, so we're gonna directly use the two adds. We're gonna delete it, and what left behind is only 3. So there's only 1 removals. Yeah. Or another case, if they are equal, we can also split it. As you can see in this example, if we are not split it, there's only 1 removals. But if you split it, no matter how you split it, there will be more removals. Because basically, if you split it, it's going to be at least 2 removals, because there are left part and right part at least 2 removals. Yeah. And for this one, if you split it from here, this is 1 removal. And for the right side, maybe you split here, this is another 2 removal. It's going to be 3 removals. Yeah. So this is why we're going to choose 2 different ways, and it's going to be the minimum of the 2. One is we're going to remove from 2 adds. Yeah, another way is we're gonna split it. Yeah, this is I think the difficult part for if they are equal. Now for the final return, I'm gonna return this result, as the result is stored in a hash table because we use the cas. Yeah, normally it can pass. But before that, let's analyze a little bit about the time complexity. This n is 100, so this I and j 100, and there's a for loop. And this for loop is another 100. So this means that it is 10 to the power of 6. And normally for the interval dp, it is designed for 10 to the power of 6 you can pass. Otherwise, if it is 10 to the power of 7, definitely you cannot pass by using this DFS plus memorization. Yeah. But let's just check the testing cases to see if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all testing cases. As you can see, it passed for all testing cases, and I think the speed is still okay. Yeah, if you don't like this kind of speed, it is like 3 or 4 seconds. You're gonna change it to tabulation, the real DP. but I believe this is okay because this is more easier to understand. Yeah, we are going from the big problem, it's gonna be 0 to n minus 1, and we're gonna split it, and we're gonna check it, make it smaller until I equal to z or I plus 1 equal to z, and then we're gonna get the final result. Yeah. So that's for this question. Thank you for watching. See you next time.